You are reading this sentence right now, and you have absolutely no way of proving that's real. Not the screen, not your hands, not even the fact that you think you're reading this. And the scariest part? Some of the smartest people on Earth agree with that. Stay with me. Hey, I'm FactSpark. If you're new here, this is the place where big ideas get drawn out simply, explained honestly, and never dumbed down. Hit subscribe so you don't miss what's coming next, because today we're going deep. So, do we live in a simulation? Before you roll your eyes and say, oh, this again, hear me out. Because this isn't just a fun thought experiment for bored philosophers. There are actual scientists, actual equations, and actual peer-reviewed research touching on this question. And the answer, or rather the terrifying lack of one, will change how you look at literally everything around you. Let's start with something you already know. Computer simulations. Scientists use them constantly. You want to model a hurricane? Simulate it. You want to test a nuclear reaction without blowing anything up? Simulate it. You want to learn how to fly a commercial plane without dying? There's a simulator for that too. And those simulators, they look increasingly real. You can fly over New York City today in a flight simulator with a level of visual detail that would have seemed like science fiction 20 years ago. Now, here's where it gets interesting. Imagine a civilization, not ours, but one far more advanced, that reaches a point where they can simulate not just weather or planes, but entire worlds. And not just visually. We're talking about simulations so detailed, they replicate brain function, consciousness, emotions, the behavior of subatomic particles, the feeling of stubbing your toe. Everything, down to the last electron. At some point, someone in that civilization asks, wait. And that's the question that starts to unravel everything. Here's what I want to know from you right now. Drop it in the comments. If you found out tomorrow with absolute certainty that we live in a simulation, would you change anything about your life? I'm genuinely curious. Come back to this at the end of the video, because your answer might actually shift after what you're about to hear. Now, the idea of a fake reality is not new. Not even close. In ancient China, a philosopher named Zhuangzi wrote about dreaming he was a butterfly, fluttering around, happy, free, completely unaware he was a man. Then he woke up, and sitting there as a man, he couldn't shake the question. Was he a man who had dreamed of being a butterfly? Or was he actually a butterfly right now, dreaming he was a man? There is, he said, necessarily a barrier between the two. But can we always find it? Ancient Greek philosophers played with similar ideas. Later, René Descartes, yes, the I think therefore I am guy, went even further. He imagined an all-powerful evil demon whose entire purpose was to deceive him. Not just tricks, a complete, perfect illusion of an entire world. Fake sky, fake hands, fake sensations, everything fabricated. His conclusion? The only thing he could be certain of was that he was thinking. Because even a deceived mind is still a mind doing the deceiving. Sound dramatic? It is. But fast forward to 1989, and you have physicist John Archibald Wheeler proposing something that sounds almost computational, that the universe is fundamentally made of information. Not matter, not energy, information. He coined the phrase it from bit, meaning that every particle, every field, every corner of space-time ultimately derives from binary yes or no answers at the deepest level of reality. The universe, in his view, was calculating itself. That idea laid important groundwork, but the person who really formalized the simulation hypothesis into something resembling a rigorous argument was Nick Bostrom, a Swedish philosopher, in the early 2000s. He turned it into a probability argument, a trilemma, actually. Here it is. At least one of these three things must be true. 1. Almost all civilizations go extinct before they ever develop the technology to run realistic simulations of minds. 2. Almost all technologically advanced civilizations simply choose not to run those kinds of simulations. 3. We are almost certainly living in a computer simulation right now.
Think about the math behind option 3. If even a handful of civilizations reach that level of technological power and run simulations with conscious beings inside them, the number of simulated minds would dwarf, completely overwhelm the number of biological ones. If there are 999 billion simulated minds for every 1 billion organic ones, then statistically speaking, your odds of being one of the real ones are less than 1 in 1,000. That's less than 0.1%. Let that settle. Now, why should you keep watching?
Because here's where it stops being a philosophy lecture and starts becoming a genuine scientific debate. And there are serious cracks in the argument that nobody talks about. The biggest problem with the simulation hypothesis is that it assumes something enormous without proving it, that you can reproduce the laws of physics using a completely different underlying algorithm. Not the actual laws of nature as we know them, but a fake version that looks identical from the inside. And right now, nobody has any idea how to do that. We can approximate physics in simulations, sure, but approximate is doing a lot of heavy lifting there. The moment you look closely enough at quantum behavior, at the precision required by general relativity, at the standard model of particle physics, the cracks appear. Running an accurate enough simulation of even a tiny corner of reality would require computational resources that stagger the imagination. And there's another problem. The simulation hypothesis doesn't explain itself. Okay, we're in a simulation. Run by whom? On what hardware? Where? What are the rules of that outer reality? You've just moved the mystery one level up without solving anything. And what about the civilization running our simulation? Are they in a simulation too? You get an infinite regress that explains nothing and only deepens the problem. Then there's the counter-argument from a Stanford student named Brian Eggleston, who found a genuinely elegant flaw in Bostrom's math. The simulation argument relies heavily on our descendants building these simulated universes. But the moment they do build one, we would know with complete certainty that we are not inside that particular simulation. We can point to it and say, that's the simulation, and we're outside it. So we can never actually use future simulated populations to calculate our own odds of being simulated. The numbers Bostrom uses don't apply the way he claims, because we'll always have a reference point, and that reference point removes us from the calculation. So where does that leave us? Here's an interesting reframe. If we accept that we don't yet have the technology to simulate a full, perfect reality, and we clearly don't, then there are really only two options for us right now. Either we are a real civilization on our way toward eventually building those simulations ourselves, or we are already a simulation running inside something else. No infinite chain, just real or not real. And if those are truly the only two live options available at our current stage of development, then the probability splits roughly in half, 50-50. That's not nothing, but it's also not the terrifying, you're almost certainly not real argument Bostrom was making. It's just uncertain, and we are very comfortable with uncertain. Now, here's where things got genuinely interesting recently. A paper published in the journal AIP Advances explored whether a law of physics could actually support the simulated universe hypothesis. It builds on the work of physicist Melvin Vopson, who has argued that information has mass, that every elementary particle stores data about itself, almost like a biological organism stores DNA. In 2022, Vopson described what he calls the second law of infodynamics. Here's the setup. The second law of thermodynamics says that entropy, roughly speaking disorder, always increases or stays the same in a closed system. Things fall apart. That's the universe's default setting. But Vopson looked at information systems and found something strange. Information entropy doesn't follow that rule. Instead of increasing, it stays constant or even decreases over time. Systems organize themselves, patterns emerge, information becomes more efficient. And here's the twist that connects it to simulation theory. In three specific areas, biological systems, atomic physics, and cosmology, this law shows up in ways that look less like natural emergence and more like optimization.
like something is actively cleaning up the code. In biology, genetic mutations don't appear to be random noise. They follow patterns governed by information entropy, as if the system is being edited toward efficiency. In atomic physics, the way electrons arrange themselves in multi-electron atoms minimizes their information entropy. They don't just find any stable configuration, they find the most compressed one. And in cosmology, when you apply the second law of infodynamics to an expanding universe, it holds, consistently, as a cosmological necessity. Why does this matter for simulation theory? Because compression and optimization of redundant data is exactly what a computer does when it's trying to save memory and processing power. If the universe is naturally eliminating information waste in a way that mirrors data compression in software, that is either a remarkable coincidence or a hint that something computational is happening at a level we can't yet access. Of course, as a simulated and compressed universe, ours would need to be running on something deeper and more complex, which opens up an entirely new set of questions that nobody currently has the tools to answer. So, do we live in a simulation? Honestly, we don't know.
The simulation hypothesis is not science in the traditional sense. It doesn't make testable predictions that we can verify. It can't be falsified. It doesn't tell us anything specific about the universe that we didn't already know. Most physicists treat it as an interesting philosophical position, something you can believe or not believe, but not something you can prove. But here's what makes it worth taking seriously. It forces us to question our most basic assumptions about the nature of reality, and science has always progressed by doing exactly that. So for now, keep living your life. Pay your bills, call your mom. And if tomorrow someone announces definitive proof that this is all a simulation, I'll be right here with a video about what to do next. But until then, go back to the comments and answer that question I asked earlier. If you knew for certain this was a simulation, would you change anything? Because after everything you just heard, I have a feeling your answer might be different now. If you made it this far, you clearly like going deep on ideas that matter. Subscribe to FactSpark so you never miss the next one. See you there.